Good morning, my plant-loving friends. Welcome to your Daily Plant Pulse, a podcast-styled series rooted in my deep fascination with plants. Here, plants go through a plant pulse research protocol where we uncover fascinating insights from scientific studies and share them with you. All studies I review are sourced in the description. I'm not a doctor, just someone who loves to research plants and present what I find. Our 9-part series takes you from an introduction to the plant through amazing studies and even an occasional bonus episode. Be sure to check out our Plant Pulse playlist where all of our episodes on all plants will be. And when a plant profile review is complete, explore our Living Library playlist for an in-depth consolidated review. We dig deep into history, forgotten studies, and untold stories so plants can have a voice and their story can be told. Welcome to episode 10, a special bonus episode where we explore the suppressed side of the plant world. Every so often, a plant's story leads us beyond biology and into the realm of history, economics, and influence, where past discoveries met suppression and curiosity collides with control. In these rare episodes, we follow the trails that don't always make the headlines. Patents, policy shifts, conveniently forgotten studies, and stories that quietly vanished from the public's eye. We're not here to speculate, but to observe what's been left unsaid and bring into the light. The truth speaks when it's given the light. Sometimes understanding a plant means understanding the world that silenced it. So today's pulse is all about the economics behind cancer treatment and the ecological interventions that may intersect with plant-based compounds like Diosgenin. We are looking at how two Yams species, Dioscorea alata and Dioscorea bulbifera, fit into a much larger story about pharmaceutical revenue, regulatory action, and the use of biological control. Let's start with the numbers. The global cancer treatment industry is massive. In 2023, cancer drugs alone generated $223 billion in revenue. That figure is expected to climb to over $400 billion annually by 2028, and that's just one segment. The broader cancer therapy market, which includes drugs, diagnostics, and services, is projected to reach $243.6 billion by the end of this year, 2025, and $404 billion by 2030. Even cancer treatment facilities themselves are part of this growth, with revenues projected to rise from $46.7 billion in 2023 to $78.7 billion by 2030. These numbers reflect a global investment in cancer care. They also highlight the scale of the industry and the financial momentum behind it. Chemotherapy remains a major market segment. Cytotoxic drugs that kill cancer cells still dominate in many regions, despite decades of development and billions in spending. Survival rates for many cancers remain modest to low. This has led to ongoing questions about the cost-effectiveness of current treatments, and the pace of innovation is despicable. Now, within this context, let's talk about Diosgenin. Diosgenin is a plant-derived compound found in high concentrations in certain Yams species, particularly Dioscorea alata and Dioscorea bulbifera. It's known for its structural similarity to steroid hormones like estrogen and progesterone. In research settings, Diosgenin has shown potential to modulate cell signaling, support hormone balance, and even inhibit tumor growth in animal models. While it's not currently used as a mainstream cancer treatment, its biochemical properties have attracted attention for decades. And this is where the conversation shifts. If a natural compound like Diosgenin could support hormone therapy, cancer prevention, or other therapeutic uses, it might offer an alternative to some of the most profitable treatments in modern medicine. That possibly introduces tension. Because in an industry projected to exceed 400 billion annually, any alternative, especially one that's natural, abundant, and difficult to patent and uncontrollable, could disrupt existing pharmaceutical models. This leads us to a very specific ecological intervention: the air potato leaf beetle. Native to Asia, this leaf beetle was selected and introduced to the United States as a biocontrol agent, specifically targeting Dioscorea bulbifera, the yam that contains the highest compound of Diosgenin. After extensive research and host specificity trials, the beetle was first released in Florida in 2011. Its larvae and adults feed exclusively on Dioscorea bulbifera, consuming its leaves and weakening the plant's ability to reproduce. Over time, this biological pressure reduces the plant's spread and vigor. The development and deployment of this program has been substantial. Between 2004 and 2011, initial development costs range from $1 to $2 million. Ongoing mass rearing and distribution have cost between $500,000 and $1 million annually. By 2025, the total investment is estimated to reach between $8 and $15 million. The stated purpose of this program is ecological: to control an invasive plant species, Dioscorea bulbifera, also known to grow aggressively, climb trees, and outcompete native vegetation. It reproduces through aerial bulbils and thrives in poor soil, making it difficult to manage once established. But here is the nuance. Dioscorea bulbifera is not the only yam species with invasive traits. Other species also climb, spread, and compete with native plants. What makes bulbifera unique is its high Diosgenin content. It's one of the richest natural sources of this compound, and the beetle targets only this species. It doesn't feed on other yams. It doesn't affect Dioscorea alata, Velosa mexicana. It feeds exclusively on bulbifera. This specifically raises questions. When ecological action coincides with economic interests, how do we separate environmental stewardship from market protection? Is the beetle deployment purely about invasive plant control, or does it also serve to suppress a plant with biochemical potential that could rival the largest pharmaceutical income producer in the world? And who funded the research for this insect? There's no documented evidence that the beetle was introduced for economic reasons. The official rationale is ecological, but the outcome is notable. A living intervention now exists against a plant that could, in theory, offer an alternative to some of the most profitable treatments in modern medicine. This doesn't mean Diosgenin is a cure. It doesn't mean bulbifera is a miracle plant, but it does mean that its potential deserves attention. Why are human trials not being done? Why is it limited to cell cultures and mediocre rat treatments? And when it is done in human hosts, why is it so underfunded and undervalued and underrepresented? And when that potential intersects with billion-dollar industries, it's worth asking how decisions are made and what factors influence them. So today's pulse has taken us through the financial scale of cancer treatment, the therapeutic possibilities of Diosgenin, and the ecological control of a plant that carries it. It's a complex story, one that blends science, economics, and environmental policy, and it invites us to look deeper at how natural compounds are treated when they challenge the status quo. That's where we'll pause for now. Next time, we'll dive into the Diosgenin-rich yams that are cultivated globally but restricted in the US, raising concerns that profit protection may outweigh public health.